For this lesson, we are going to learn how to find the y-intercept if the slope does not fall on an exact value of y, okay? In our other examples, the y-intercept, the slope hits the y-intercept on exact values like here, here, here. So it's very easy to figure out what the y-intercept is. But something like this, you don't know whether it's like, is it in the 1/4, 1/2, or 1/3, okay? So this is one technique that you can use to figure that out, okay? And what you're going to do is to use algebra, solve by substitution, okay? So the first thing you have to do is to find the slope, because once you know this is the equation, okay? mx plus c, okay? Oh my God, they're all variables. How am I going to solve this? First, we need to figure out what the slope is. So there are many ways of finding the slope, okay? One way is we know that slope is equal to rise over run. So let's calculate. So the rise for this one would be 1, 2, 3, 4, 5. So it's going up. Therefore, it's a positive 5, okay? And then we go 1, 2, 3. It's going to the right. So that's a positive 3. So this is the rise. So the rise is positive 5. And the run is positive 3. So that's our slope, 5 over 3. Or sometimes you might want to, you might want to do it the other side. It's going to end up the same, okay? So let's count. 1, 2, 3, 4, 5. So it's going down. So that's a negative 5. And then we go 1, 2, 3 to the left. So down and left, that would be negative. So in this case, you have m is equal to minus 5 minus 3. But we know that negative over negative will give you positive, okay? Negative divided by negative is positive, and so you still end up with the same, okay? Now, you might want to try using rise over run. The slope formula. Oh, it's too dark, okay? So, m is equal to y2 minus y1 over x2 minus x1, okay? So let's figure out what is this coordinate point. So this coordinate point is negative 1 and 1, 2. Negative 1 and 2. While this point would be, okay, 1, 2, 3, 4. Negative 4 and 1, 2, 3. Negative 3. Okay, so let me write that down here. We're using, or let me label it. So this would be my x1 and my y1, and this would be my x2 and my y2. Then all you have to do is to simply substitute. What is my y2? y2 is negative 3. y1 over here is minus 2 divided by, this is my x2, okay, minus 4, and this would be my x1, x1, okay, minus 1. Now, please, do not assume that this negative sign takes the place of the negative sign here. That's why it's good practice to write down minus, and then if the value is negative, put it in brackets so you don't forget, okay? So we end up with minus 3 minus 2 is minus 5 over negative 4. And what's this? Negative times negative is positive, so that's negative 4 plus 1. So that's equal to negative 5 over negative 4 plus 1 is negative 3. And since negative divided by negative, as we saw here, is a positive, your slope is 5 over 3. Okay? 3 different ways, we got the same value. Okay? So let's go back here. We know now that our slope is 5 over 3. But miss, there's still 3 variables. How are we going to solve it? Easy. Can you figure out what x and y are? Of course, you have the coordinate points. These are your x and y, so just choose which one do you want to use. So let's say I want to use this set, okay? I want to use -1 and 2. I know this is x and I know this is y. So I just substitute. So this is what you call solving by substitution, okay? So I know y is 2, so that will be 2 is equal to, slope is 5 over 3, x is -1 plus c. So now you end up with only one variable, c. So now you can solve it. So this becomes 2 is equal to -5 over 3. Miss, why did it become -5 over 3? Because I multiplied +5 over 3 by -1. Negative times positive is negative, okay? Plus the constant. Now, just to remind you, in algebra, we want to isolate the variable. So that means we want c to be by itself, okay? So we need to get rid of this. We need to transpose it to the other side. And to do that, we need to do the inverse or opposite operation. So if this is negative, we want to add 5 over 3. Why? Because we want this to equal 0. Okay, so that 0 plus c is just c. 0 has no value. And whatever you do to this side, you need to do to the other side. So plus 5 over 3. Okay? So this becomes -5 over 3 plus positive plus 5 over 3. It becomes 0. So this one you're left with 2 plus 5 over 3 equals c. Okay? So now, how are we going to add this 2? Well, there are many ways, but let's do it. Let's try the first one, okay? By getting rid of the fraction. And we do that by multiplying both sides of the equation by 3. Miss, why 3? Because that is the denominator that we want to cancel, okay? I will show you that later. Now, we need to distribute this. So 3 times 2 is 6. And then plus 5 over 3 times 3 equals 3c. Okay? Now let's look at this over here. 5 over 3 times 3. Okay? Multiplying fractions is the easiest thing to do. And one thing you have to remember that all whole numbers have a denominator, which is 1. And when you multiply fractions, it doesn't matter whether or not the denominators are the same or different. You just need to multiply the numerator by the numerator and the denominator by the denominator. So 5 times 3 will give you 15. Okay? 3 times 1 will give you 3. And you simplify, so 15 divided by 3 becomes 5. Okay? Another way of doing it, you have 5 over 3 times 3. Now, if the numerator is the same as the denominator, you can just cancel. And you are left with 5. Okay? So that's what's going to happen with this one. So you're left with 6 plus 5 equals 3c. 11 is equal to 3c. And again, we want to isolate c. So since this is multiplication, the opposite or inverse operation is division. And I want to divide it by 3. Whatever the coefficient is, that's going to be your denominator. And if I divide this side by 3, I need to divide this side by 3. So this cancels. C is equal to 11 over 3. Okay? So, what is the other way? Okay, so let's go back to this part. Okay, so I have 2 plus 5 over 3 equals C. Okay, so I can just make this into a mixed number. So this would be, okay, 5 divided by 3. So let's look over here. How do I make 5 divided by 3 into a mixed number? So it's 5 divided by 3. So you end up with 1, 5, 3. 5 minus 3 is 2. So you end up with 2 plus 1 and 2/3 equals C. Then since they have whole numbers, I can just add it. 3 and 2/3 equals C. But miss, it's not the same. Okay, let's check. Can I make this back into a fraction? Sure. How do you do that? Multiply the denominator by the whole number. So 3 times 3 is equal to 9, and then add the numerator. So 3 times 3 is 9 plus 2 is 11, and the denominator is the same. Same. Or I can make this into a mixed number. So 11 divided by 3 is equal to 3, 9. 11 minus 9 is 2. And again, this is, the whole number is 3, numerator is 2, denominator is 3. So it's the same. Okay? So we now know that our constant is 11 over 3, or 3 and 2/3. Now let's look at our graph over here. Okay? If we count up, you will see this would be 1, 2, 3. So the whole number is the same, 3. Now let's look at this. If I divide this into 3 equal parts, you will see that the line passes at 2/3. This is 1/3, 2/3. So you have 3 and 2/3. 3 and 2/3. Okay, 3 and 2/3. So that is your proof that the y-intercept is 3 and 2/3. Okay, 3 and 2/3. And therefore, now you have your formula, your equation. And now your equation, we know, is y is equal to 5 over 3x plus your constant, which we calculated as 3 and 2/3, or 11 over 3. Now, I would just leave it as 11 over 3 so that it's easier for you to add or subtract. Okay? Now, is our equation correct? There's one way to find out. Okay? And we call it checking by substitution. Okay? So, since we use -1 and 2 to calculate for the constant, let's check by using the other set of coordinates, okay? Let's check by substitution using -4, -3, okay? Always, please, always start by writing the formula. Don't be lazy, okay? Y is equal to 5 over 3x plus 11 over 3. Do we know what y is? Yes, y is -3. Equals 5 over 3. Do we know what x is? Yes, -4. Plus 11 over 3. Okay? So -3 is equal to, and as we know, multiplying a fraction by a whole number, okay, we know that the whole number has a denominator of 1, and then just multiply numerator to the numerator, -20 over denominator to denominator. 3 times 1 is 3, plus 11 over 3. So -3 is equal to Since they are like fractions, okay? Like fractions mean they have the same denominator. So if that's the case, I can easily add or subtract the numerators. In this case, negative 20 plus 11 equals negative 9 over 3. You do not subtract or add the denominator, okay? It remains the same. So you have negative 3 equals negative 9 divided by 3, negative 3. So that means if they're equal, that means this equation is correct. Okay? So I hope this tutorial helps you understand how to solve number 5. I leave you in my heart and I say bye-bye until the next tutorial and a smiley face. Bye-bye.